Okay, so in this video, we're going to be talking about parallel and perpendicular lines from a graph. So this is kind of moving forward into Unit 3. And so our goal here is to determine if lines are parallel or perpendicular. So one particular equation that's really going to come in handy here is y equals mx plus b, which is point slope form. So we've kind of been over how to graph these lines, and if this is confusing, then I guess we'll take a day and go over graphing lines. But the slope comes from this term here. So what value of m, whatever value of m tells you the rise over the run. So m is rise over run. And b is your y-intercept. So it tells you where your line is crossing the y-axis, okay? And so once you have y equals mx plus b, and you've solved the equation and put it in point slope form, you can start to tell what the lines are doing and graph them. So we'll do both. We'll graph them, and then we'll talk about whether or not they're perpendicular or parallel. So lines are parallel if they have the same slope. And do not intersect. So the only way that they're going to have the same slope and intersect is if they're the same line. So write a line on top of one other line would constitute as having the same slope, but intersecting. So these lines, parallel lines, do not intersect. Lines are perpendicular if their slopes are opposite reciprocals. And what I mean by that is whatever the slope is for one line, the other one will be the exact opposite as far as numerator and denominator are concerned, and it will be a negative slope. So here's the first problem we're going to do. So I'm going to give you just a minute to try and figure this one out on your own, and then I'll go over it. Excuse me there, I was shutting the door. So we've got two lines here, and we want to put them in. We want to put them in y equals mx plus b form, or point slope form. So my first line is y equals negative x plus 5, and my second line is going to be 5x plus 5y equals 20. And what I want to do is I want to solve this second equation for y. So what I'm going to do is rearrange this formula. I've got an addition here, so I've got to get rid of this 5x. So I'm going to subtract 5x from both sides of this equation. So I get 5y equals negative 5x plus 20. And then I can divide every number by 5 to get rid of that coefficient of 5. And I get y equals negative x plus 20 divided by 5 is 4. So if I graph both of these lines, first I'm going to use the y-intercept to graph both of these lines. So this first line, its y-intercept is 5. So it's going to hit the y-axis at 1, 2, 3, 4, 5. And its slope is negative 1. So anytime you see a negative in front of x, it's understood to be a negative 1. So m is negative 1 over 1. So that is your fraction. That is your slope. So from this y-intercept, this line is going to go down 1, right 1. Down 1, right 1. So this tells me to go down. This tells me to go right. So if that's the case, that is that first line, okay? So y-intercept, and then from the y-intercept, use the slope to give the direction of where to go. And so this next line is going to be the same thing. Its y-intercept is 4, so I'm going to do this in purple. So up 1, 2, 3, 4. But its slope is also negative 1, okay? So negative 1 over 1. So that's telling me to go from this y-intercept down 1, right 1, down 1, right 1. And so if you take a look here, both of these lines have the same slope. They have the same coefficient on x, but they have different y-intercepts. So they'll never intersect. So these lines are parallel. So that green is just 2 arrows trying to show you that they're parallel. So these are distinct parallel lines. So if I take a look here, they're not the same line. They're not on top of each other. They're definitely not perpendicular. They don't intersect. They're distinct parallel lines. So you can graph these, or you can just take a look at the slopes. So I'll do this one with slopes. So I'm going to give you a minute to look over this one. And you can really tell by the slope, so I'm gonna go over this, so hopefully you've had a little bit of a chance to talk about it. The only way that these are going to be perpendicular or parallel to each other is if they have the same slope or an opposite reciprocal slope. So what we're going to do is I've already got this one solved for y for a point slope form, so that one's already in point slope form. So I'm going to solve this first equation for point slope form. So I'm going to solve for y. So I've got 4x minus 2y equals negative 5. I want to get rid of this 4x. So I'm going to subtract 4x from both sides of this equation. So I've got negative 2y equals negative 4x minus 5. So then I can divide both sides by 2, or negative 2. So I want to solve for y. So I'm going to divide every single number by negative 2. And I get y equals 2x plus 5 over 2. And if you take a look here, this first slope is negative 1/2. Okay? This second slope, if I write it as a fraction, is 2 over 1. So I've got, if you take a look, one number that's in the numerator over here is in the denominator of the second line. And then one number that's in the denominator of the first line is in the numerator of the second line. And if you take a look, this one's positive and this one's negative. So they are opposite reciprocals. Reciprocal means you flip the numerator and denominator. So you'd write it in reverse. And then what opposite means that they're opposite in sign. So this one's negative and this one's positive. So just given that information, I don't even have to graph these to show or to know that these are parallel, but I will show that here in a second. So I'm just going to show you over here. They're perpendicular. They will intersect at 90 degrees, but we're also going to take a look at them in GeoGebra. So hopefully that loads. And for some reason it is not. So okay, there we go. So this is just a fancy calculator that allows me to graph both of these lines. I'm not sure if I don't think we've used it in class yet. What a shame. I don't know, we've used it in class once, but we'll be able to use it some more. So first of all, I'm going to graph this first line, negative 1/2 x minus 1/10. So y equals negative 1/2 x minus 1/10. That's that line, okay? The second line we just solved for is 2x plus 5/2. So if you take a look here, it doesn't take a rocket scientist to see that these two lines are forming a 90-degree angle all around. So they are perpendicular lines, okay? And that's essentially what you want to do. You want to be able to graph these lines and see if they are perpendicular, parallel, the same line, or if they intersect but they're not perpendicular. So we'll just do one more, and I'll call it a day. So I've got y minus 3 equals 2 times x minus 3, and y plus 5 equals 2 times x plus 1. So what I want to do is I want to distribute this 2. And so I get, for the first one, y minus 3 equals 2x minus 6. And for the second one, I get y plus 5 equals 2x plus 2. So I haven't solved for y yet. So for this equation, I'm going to add 3 to both sides to get y alone. And so when I do that, I get y equals 2x minus 3. Negative 6 plus 3 is negative 3. And then here, I want to get rid of this positive 5. So I'm going to subtract 5. And so I get y equals 2x minus 3. And so what's nice about this is I can kind of see that these are both the same equation. So if you get the same point-slope form of an equation for two different lines, it means that they're not distinct. It means that they're the same line. So if I go back over here, even though they don't look the same at the very start, when I worked out that problem, we found that they were the same line. And so that's all I want to talk about for this video. So I hope that helps. Make sure that you know y equals mx plus b, and you can solve an equation that's in a different form for y, and that should set you straight. Also, I would also know opposite reciprocals to, if I have a fraction that's negative and I have a fraction that has the exact opposite that's positive, the slopes, for those slopes, it means the two lines are going to be perpendicular. If you have the same slope, it's either the same line or the lines are parallel. So yeah, that's what I wanted to say. So have a good